Welcome to the project demonstration of multi-input soft switching DC to DC converter to connect renewable energy sources to DC microgrid. So here the main application of this project. So based on the multi-input, and we are going to connect them to the grid microgrid by using this is the Cuck converter. The Cuck converter main purpose is which will acting as a buck and boost converter, and which will provide us the inverting output based on the input polarities. So that will be controlled by the PIC microcontroller based on the continuous input voltage sources measurement. So we are using as of now two voltage sources. One is the wind and the solar, which are renewable sources. The output of these sources is input to this battery pack through the direct charging circuit as well as through this Cuck converter. So here the parallelly this charging circuit consists of four inputs. So in that one is the grid, another is the Cuck converter outputs, another is the solar, and another is the wind. The solar wind output from this regulated power supply board is parallelly connected to this Cuck converter. We can see this. So here you can see the solar and wind connected the two sources. Okay, and the output of this rectifier circuit, nothing but here we are using the bridge rectifier and capacitor and two diodes, LED indicator. So this bridge rectifier will acting as a polarity corrector, means whenever the wind rotates in clockwise or counterclockwise, that will be rectified with the help of this rectifier circuit, and filtration just to remove the pulses. Whenever the after rectification, there will be chances of pulses will be generated. And the next two diodes, we can see that the two diodes purpose is which will act as a unidirectional current flow, means the battery voltage or Cuck converter voltage will be not given to the wind reverse. Same for the solar panel also, but in the solar panel case, this rectifier IC will acting as a polarity corrector. So here also, like a directional based rectifier, here polarity corrector. If you place the solar panel connection in reverse polarity, then that will be rectified in order to protect the battery or Cuck converter from the reverse polarity fault. And so these are two rectifiers. After that, input to this Cuck converter, and parallelly this Cuck converter voltage is measuring by the microcontroller. So from there, the output of this Cuck converter we are going to continuously measure with help of this voltage sensor to the microcontroller pin. And based on the input voltage from the sources, so whenever the input voltage is at least of 8 above volts and below 12 volts, then the system will control this Cuck converter to provide maximum voltage to make a charge of this battery pack. Coming to the battery packing, we are using 12 volt 2 amp battery pack. So in this battery pack, we can see the 4 volt 1 amp batteries number 6 available. In that, these three are in series, these three are in series. So we'll get 12 volt 1 amp, and these two are in parallel. So we'll get 12 volt 2 amp DC outputs. And after this, the grid will be generated, means it was connected to the grid with help of inverting circuits along with the step up transformer. So the inverting will be achieved with help of this IC and two MOSFETs, which will invert the DC input to the AC output of 12 volts, and that will be step up to the 230 volts with help of this step up transformer, and that will be connected to the AC grid, as well as direct 12 volts DC will be connected to this DC grid. So here the charging station along with DC grid and AC grid, means DC to DC and DC to AC. Here the DC to DC will be converted whenever the input voltage sources will be available to this one. And here the microcontroller will taking care of measuring the voltages from these three voltage sensors. Cuck converter, so as we showed, this is a Cuck converter, and this one is the solar panel. So parallelly we are giving this solar panel voltage to the microcontroller as well as to the Cuck converter input through the rectifier IC, and this is the wind. Okay, so wind input also to the microcontroller as well as to this inverting circuit. So here these two transformers, which are using them as inductors. So means for providing the high current with high voltages, we are using this inductors with a rate of 200 microhenry. And this is a step down transformer which is used to charge our battery pack whenever there is no the source is available. So this is not the part of the project while demonstration. It's only safety charger. Before demonstration, we should keep the battery under charging. So next, the only main step is before demonstration of the project, keep the battery under full charge at least of 5 to 6 hours. Till the duration, keep it on charging. So we can see the LED status which is getting available from this system as the power is available from this microcontroller. And the next, this is all about the components wise, and let us see the demonstration. So once this is the main on off switch. So once we on this, there is, you can see the welcome message on the LCD screen, as well as the solar panel voltage. As of now, we are placing this under the roof. That's why low lighting, the low voltage is available, and that will be displayed on the LCD screen. So we can place more lighting on that, so that we can get the more voltages, right? Okay, slightly increasing the voltage. Okay, so when we carve up this totally, you can see the voltage is decreasing. Okay, and coming to the wind, so either of the directions, so you can see the wind voltage. Okay, so whenever the wind voltage is more than 8 volts, then it will boost up that. You can see that. Right, have you seen that 8.1 and the converter output? We can see that. Yeah, so due to the reverse pulses, if we get an error, just to reset the system. So right, you can see the 10.51 whenever the voltage is getting from the wind is 8 volts. Same from the solar panel also. Parallelly, we are measuring the both and applying the converter pulse signals to this MOSFET from the microcontroller. So the microcontroller is a closed loop, continuously measuring the voltage and controlling the pulse signals to this MOSFET board. And this is another secondary input to the MOSFET. If you want to control that from externally, switch off the motherboard, then you can control this from the external pulse input to measuring the working performance of converter. And coming to the grid application, so once we on the switch, and we can utilize that for the DC to AC application along with the step up, and this is the DC to DC grid applications. Okay, so in this manner we're going to achieve the multi input along with multi output, so DC to DC converter and DC to AC microgrid applications. And ratings, coming to the ratings, we are using this 12 volt 20 watts DC dynamo, which can generate up to 14.5 volts maximum based on the rotations. So if it rotates for 1000 rotations per minute, then it can generate up to 12 volts. If it is more than done turns, then it will provide the maximum 14.5. Coming to the solar panel, we are using the 12 volt 5 watt solar panel. Though we are using that, there we are going to get the maximum of 17.5 volts. So you can see the 17.4 volts along with wattage also is mentioned. 12 volt 5 watt solar panel, and battery rating is 12 volts 2 amp battery pack. Right, thank you.